Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about rocket economics. So let's dive right into it. Now, these puppies are expensive, but we have to understand how expensive. There is like things like expensive like a G-Shock or expensive like a Rolex. They're both expensive, but like different scale. So most people are familiar with industrial world because again, sooner or later you may interact with someone who's dealing with industry and industrial kind of cost, and those are expensive. Meaning you can have same amount of horsepower motors in your household versus the same thing going into your let's say power plant, and you're like, dude, the power plant motor is far more expensive. Again, uptime, reliability, maintainability, all those jazz go into making sure those things have as high uptime as possible, but again, consequence costly. So what is the most expensive industry that we human kind of even think about? That is generally aviation industry. Now, here's the aviation is expensive. Let's not kid about it. These planes are expensive. Per kilogram, their cost is idiotically high. Like it might has been made out of low grade like around 18 karat gold, not 24 karat, that will be a bit expensive, but 18 karat gold. Like specifically the turbine blades that go into jet engines, those are actually one of the most expensive thing, like from a kilogram point of view, like genuinely expensive. So these things are expensive, but here's the deal. Rocket engine alone, I'm not talking about the whole rocket system, just the engine alone will make all of these look cheap. How cheap? $20 million for this plane. Awesome. Rocket engine, $500 million. One rocket easily touches $1 billion. Like space shuttle, that puppy crossed $1 billion per launch. So let that sink in. Like the amount of zeros we are talking about when we are talking about rocket is on a whole different level. So G-Shock versus Rolex. So you have to understand that. And why it is that? Is that like some evil corporation is like, I'm going to exploit things? No, it's very simply because there are too many vectors working on it. Meaning, whenever you're talking about aircraft, you're talking about somebody who can understand aerodynamics. You are talking about somebody who can understand metallurgy. You also need someone who can understand rubber science. Otherwise, like the moment you touch a runway, boom. So you need this sort of different kind of people. You also need unique people who are qualified to work at 400 hertz electronics. You're like, what the hell? Yeah, AC electronics used in these puppies are 400 hertz. Again, it does allow you to make motors, compressor, all the jazz very small. So that's why used in aircraft. But you get the point. Like these things have that. Now imagine all of this plus whatever field was remaining, add all that, then you come to rocket level engineering. So it's very diverse. You may think, oh, I just need few people. Now if you are dealing with a startup, they may be like 1 or 2% will try to take literature that is created by NASA, because NASA is a publicly traded kind of scenario, not traded as like traded information, publicly open information. So you will extract that information. But if you have to do a proper company like SpaceX, you'll need a lot of people and in lot of domains. So expertise is expensive, flat out. There is no around it. There is no way going around it. You have to pay for expertise. And then we have to deal with permits. Now permits could be so goddamn expensive that you're like, why? Well, you have to understand this. Whenever you're talking about anything that can go into orbit, it inherently has the probability of hitting anywhere on the planet. And God help you if somebody decided to, you know what, I would really love to start World War III, so they could like literally put a nuclear warhead on a satellite, like well disguised satellite. They're like, yeah, this is a satellite, this is a normal observatory. And again, they could have like basic 1 cube satellite and all that jazz, and they have big thrusters. They're like, for positioning and all that jazz. And they're like, everything is awesome, a satellite is going there, and it's slowly shifting. So does not raise any alarm. It's like very slowly, like it may take a month to change the orbit such a way that it crosses over something, and boy, nobody saw it coming. World War III. So that's why permits are so important, because we humanity as a whole have agreed upon, it's like, bro, if you are launching it, as in like if India, whole of India launches anything, somebody in India has to be responsible. So who is responsible? Government. Who exactly in government? ISRO. Same goes with America. It's like America launches anything, who's responsible? NASA. NASA has to give the permit and have to give the stamp. So you can understand that. Like even if you are in the position of like NASA, would you just allow any Tom, Dick and Harry to have any ability to launch things? The permits are expensive for a reason. And again, they are very tedious, but for a reason. And there is another aspect, meaning what will happen if Rolex disappears tomorrow? Nothing major. But what happens if GPS disappears tomorrow? Serious damage. So that's one of those things. Like, why the heck these things are so expensive and still being made? Simply because the demand for these services that they provide, as in the rockets, is very important for us. How important? It's touching everything and every day, meaning you will not be able to cross 1 or 2 days if we literally lose space assets. commerce relies on it. Meaning, imagine it this way, like, would you have this sort of gig economy, like the amounts of people who are employed simply because now we have GPS and any Tom, Dick and Harry can actually go anywhere and deliver anything. Again, taxis can just do services that was not possible without GPS. Like we have, how the heck we have cross-continental delivery systems? GPS. Communication, many satellite communication is very important simply because many offshore systems, boats, aircrafts, all of those things rely on satellite communication. Observation, meaning, for example, let's say India has a forestry department. Department is auctioning of land. Now, here's the deal. The amount of land forestry department has to take care of, it's equivalent of a country. It's like, that's how they work. But here's the deal. Can they actually have even one person per hectare? Hell no. They're going to run out of India people very quickly. So, or the cost will become so exponential that they're like, bro, we'll go to ISRO, can you make a satellite that allows us to observe forestry, specifically hyperspectral camera that is fine-tuned for vegetation, so we can observe if like we are selling off this area, we'll coordinate it up in the map, and then like if you go above it again and again, and then keep checking like, hey, the contractor that went there, like they're supposed to be in this line, and somehow they're like 10 feet under it, then you can observe it that well. So observation matters. And again, observation in other ways like hurricane, typhoon, weather events, all those things matter. It's very important, and that's the reason why somebody can even think about installing something this expensive. So what were the toolings? What kind of tools we use? Well, here's the deal. Every tool in human arsenal, meaning if you are talking about a big rocket company, let's say like ULA or SpaceX, there is a very good chance there is a tool engineer who knows one tool that you are looking at. For example, mills, CNC mills, everybody has it. Lasers, everybody uses it. EDMs, everybody uses it. Diffusion bonding, everybody uses it. Meaning every single tool that humanity has, including 3D printers, including technologies that may not have been mass produced yet, still like it will be there in rocket industry. That's my guarantee. Like you go to a rocket mass manufacturing company, you're like, things that it does not even make sense. Like this is how SpaceX makes the engine bell. So yeah. So every technology is used, every tool is used, and you have to have diversity in terms of metallurgy. Metallurgy, what kind of metal? Like when you say here Elon Musk talking about stainless steel, it's not basic bitch stainless steel, it's complex stainless steel, fine-tuned for cryogenic temperatures. And when you were talking about other companies, that when they are using lithium, aluminum alloy, like think about this, like when was the last time you thought or even heard somebody mixing lithium with anything? Like we know magnesium, but have you ever heard of like lithium being mixed with a metal? Why the heck? That's the reason. Lithium, aluminum alloys are used, carbon fibers are used, titanium is used, Inconel is used. Most people are like, what the heck is Inconel? Where the heck it is in the periodic table? So you get that point. Like you need very diverse range, and almost all metals are used. And then we come to semiconductor. You need a dedicated branch of semiconductor to deal with this. Why? Because you're like, hey, what if I put Ryzen 7000 in this? It's not gonna work. The moment it crosses upper atmosphere, radiation bombardment will happen. It will like keep lid flipping. It will simply not work. We have to make large gates. Large gate as in like 200 nanometers, 400 nanometers, those sort of ranges. So computers are very old. Like, but how the heck you build an old computer? You don't. You can't buy like computers that are made in 1980s, Motorola chips that are used in space shuttle era. You have to redevelop them parallelly. So for that reason, semiconductor, you have to have a subdivision that is handling all that jazz. Then all that is compounded by the fact that you are dealing with high pressure, meaning your PSI is so small of a unit that you have to use bars, and your bars are no longer like 100 bar or 200 bar. It's like 600 bar or maybe even higher than that. So your pressure is stupid, and then temperature the temperatures that we have here, it's not hot, it's stupid. What does that mean? That simply means if you put a metal block there, it will not melt, it will evaporate. Let that sink in. Most people don't understand, like metal can easily start to melt around 1500 degrees Celsius. The moment you have 3000 degrees Celsius, that's evaporation. Your metal will evaporate. So you have to understand, you are dealing with ludicrously high pressure, idiotically high temperatures. On top of that, you also have cryogenic just for lols, because like you have a lot of pressure. Like you have negative pressure here, meaning PSI is pressing it. You have idiotically in the chamber, you have ludicrously high pressure, and the temperature is stupid all the way around. And the outside, you have almost liquid hydrogen that is almost at absolute zero. All of those is happening in one unit, millimeters away from each other. Yeah, that's why this tooling requirement for this sort of tool is on a whole different level. Like aircraft industry is like, bro, that's easy, bro. Just take it and go. Like this is like a whole different level. Like using jet engines, turbine, those are the most expensive part inherently. And these puppies, like, bro, that's like, that's just one injector plate is that kind of cost. So Whole different level. The tooling requirement is a whole different level. Then we come to the consumable parts. So to summarize, these puppies are thirsty, meaning these puppy consumes things like there is no tomorrow. For example, this is a humble F1 engine that put man on the moon. And what kind of fuel consumption this puppy had? So this had 1.7 tons of liquid oxygen plus zero point 0.7 tons of RP1 per second. Let that sink in. This puppy in grand total is consuming around more than 2 tons per second, not minute, not hour, second. Imagine what would be the size of those tanks. Like again, there is no human structure, like there is no normal building with normal windows, so you cannot understand the size of those tanks. Those are enormous balls, like hideous, and like your bank balance have to have huge balls, otherwise you're simply not able to afford it, flat out. Just the fluid cost alone is huge. And again, you will never have this ability. It was like Raptor 1, awesome, it works, go. It will have a Raptor 1, boom, Raptor 2, boom, Raptor 3, boom, Raptor 4, hey, it worked for 5 seconds, Raptor 6, boom, Raptor 15, boom, Raptor 21, finally it works. So that's just the engine cost. Don't even think about how much fluid you have to spend. So for every time you see, like, Bokujika, they have liquid nitrogen and all that jazz, that's not cheap. And again, 1 liter of liquid nitrogen, something YouTuber can afford. 50 liters of it, a bit expensive, but can be managed. 5,000 liter of it, yeah, no, that's expensive. And imagine 500 tons of it. Yeah, it went stupid. So you have to understand that just the fluid cost alone, and again, you may also have to pay for helium, which is very expensive. And the amount of helium used, again, one mission may not be enough, but if you are launching multiple times a day, helium pressurization alone will be like, yeah, how much money we are paying for helium? Let's not talk about it. So you have to say rockets are, and not to mention, other than Falcon 9, almost all rockets are consumable at this point in time, meaning all this brilliant machinery is yeet. Nothing else, just use it once and yeet it out there. And again, this will be the end of all your rocketry. So that's expensive. And then we come to failures, because no matter what you do, no matter what you build, no matter how good you are, something is gonna go wrong. There is Murphy's law, and that's the law, like law kind of law. So it cannot be broken. Sooner or later something bad is going to happen. At that point in time, the penalty of something bad happening is exponentially cruel. You may think like aircraft crashing would be bad. This puppy will make it like from a financial sense on a whole different level. Like you may not be able to understand. Like many times you'll say SpaceX is the cheapest, then why the heck not everybody uses SpaceX? Again, insurance, there is a whole different ball game of insurance that you're like, do. And insurance premiums are very high. Why? Again, insurance, when they are giving you insurance for car, they know the grand statistics. They know, like, 99.9% of the chance you will drive a car and you will arrive safely. And even if you have an incident, chances are that you're going to walk away with it. So they know. That's why that's how they adjust their vector. They're basically how much they're going to charge you. But imagine if like every other flight started to crash, or every 10th flight, what would be the insurance premium? These things are not that reliable. So they have very expensive insurance. Very, very expensive. Those are consumables. Then we come to the another aspect that you cannot just buy with money. Like this is the skill set department, and there are very few people working on it. To give you a context, SpaceX, big boy. It has 12,000 people working in it. That's some serious amount of people working there. Yes, there's a small company in India that is known as Tata. It has a small division known as Tata Consultancy Services. It has 600K people. To give you a context, Microsoft employs around 1.5 lakhs people, 150K. Google, Microsoft, most things are around 150K people. Amazon also. TCS is that high. Again, it's a consultancy services, so it's serving a lot of other people. And again, if you go to Bangalore, we have more than this many people working in IT department in that city itself. So to give you the context, and those people are making a lot of money, and these people are making even more money, and there are very few of them. So the context, the talent pool availability is very small. Like the amount of people who can actually work in rocket industry, and they have studied for rocket industry from day one, not just side gliding into it. Like, no, I studied for rocketry, this is what I do, this is what that pool is surprisingly small. Like, whoa, kind of small. Like even in a country which has like 1.5 billion people, it was like, whoa, like that's small talent pool you're talking about. And you need people from all discipline, because here's the amount of stress that you are dealing with when you are talking about rocket engines. You will literally have a person whose sole job is like, bro, I know how bearings works. That's it. What are you? No, I only touch about bearings. There are the stupid bearings that you have to utilize for your basically stupid turbopumps that are rotating at 100,000 rpm. So that's their job. Like nothing else will come to them. It's like, that's it, that's my job. Then there will be one person whose sole job is like figuring out nitrogen. Another person, T-tap, I don't touch anything else, T-tap is my job. So these things mean you will have a lot of people requirement. And again, if you are talking about a startup, they will try to have multiple hats on one person, but it's not sustainable, especially on large scale. At large scale, you have to have one person dedicated for that. So you'll be surprised like what kind of people would be there. There will be one person whose sole job is like, I'm just maintaining other people, So talent pool is very small, and consequence of that, these people are pricey. Meaning you may be like, okay, this much metal, this much money, cost, consumable and all that, and then the talent pool's cost would be on a whole different level. I'm like, have you ever wondered how the heck people leaving SpaceX somehow are successfully able to manage their own company, rocket company? Yeah, like big money. We are talking about some big money. And they are one of a kind people, meaning these two gentlemen. Again, if you have somehow have a time machine, go back and poof them out of existence, you will poof the country's space ambitions. You can literally ground a humanity. So let that sink in. Like these sort of people are very rare. Even like, again, I do understand population. So trust me when I say this, like they are rare, meaning you may only have to remove as few as 5 people from ISRO at the right time. You can literally cripple a whole nation. Same goes for China, same goes for USA. Like it's like very majestic thing that we somehow able to manage it. That's the true growth of humanity, that we have that kind of talent pool where even something as rare as rocket engineering is something that enough people is there, enough people are mastering it through work and ethics and effort, that they're like, yeah, we can actually push humanity further. That's the true genius of it. The skill set is the most expensive part. You cannot just buy it. That's why China did not able to copy SpaceX. They tried it. Like, talent pool is not something you can just Control C, Control V. Then we come to the granddaddy of all, because you have to, I specify every time, you have physics, you have engineering, and you have the daddy of all, that is economics. Economics makes it go around. So market is the final limitation here, because here's the deal. Many times people have this brain damaged illusion that real estate always goes up. That's never true. Every time whatever market crashes, it always starts with real estate, because here's the deal. Your cost can only go high if people are willing to pay. For example, New York, you will like, okay, this office blocks cost like, $5 million. People are like, yeah, I'm not paying for that. Yeah, my whole company's GDP is like, 5 million. Yeah, I'm not paying for that. The same goes in Bangalore also. Bangalore is like, affordable apartments for 5 crore rupees. I'm like, what the hell, that number, it has too many zeros. Just think of it that way. It has too many zeros. So they can increase the price. But here's the deal. There are enough rich people that it will go around. But here's the deal. Eventually you will reach a point where not enough rich people is there. Like you can make a Ferrari that is like $70 billion. Nobody's going to pay for it. Like all it is just a junk at that point in time, because unless somebody is willing to buy it from you, it has no value. It's like almost like how people got trolled with NFT. It's like, yeah, this NFT is $75 million. No, I will not buy it from you for $75 million. So that's the whole thing. There is nothing like infinite growth. Same thing happened with China. It's like real estate. Dude, nobody can afford to live in the goddamn building. He's like, you have this amazing building, I'm going to charge like this much rent for it. It's like, bro, who is going to pay that kind of money to live in a building? Who has that kind of money? And the person who has that kind of money generally has their own building. So it's one of those things that's just like, I'm genuinely surprised, like humanity keeps falling for this trap again and again and again. It's like, be it 2008, be it 2020, it's like again and again we keep falling for that. So everything has a limit, because if you cross that point where it's like, this GPS technology is awesome, it's going to cost you $75 billion to use, all right, we're like, no thanks, me good. So that's the whole point. There is always a limit. Same applies for space. And rockets are easy to make. Again, because of the complexity of that, that's why I'm saying that rockets are not easy to make. It's just that after you have made rocket, making it financially valuable, you're like, dude, rocket is the easy part. It's almost like how we clear exams, and we like, when we are kids, it's like exam is the big thing, and after that, it's like, that was easy, man. Same thing happens here. Rocket building is easy. Making them economically viable, like I made this rocket makes me money. That's the hard part. And you cannot even maintain it simply because you are not in control of all the variables. For example, market forces can change outside of your control. For example, India can build PSLV. It works awesome. It's a working, reliable workhorse rocket that has around 100 launches, and it's cost effective, and we are doing awesome things. Here's the deal. This puppy can be launched around, let's say, 4 or 5 times a year. Okay, not bad. But here's the deal. These things start to come in. And all of these things are aiming for almost a weekly launch. Even though these things are a bit more expensive than that, that will literally lose all its simply market because the cadence is not high enough. So you have to understand, if you are looking from a rocket company point of view, you do not have too much control, because somebody else can come in and just like, bye, like that's exactly what SpaceX did to everyone else. So you have to understand that a market demands the service and market sets the price. Because if you are like, hey, I'm going to charge 5 million for that, again, if market requires speed, they will like, hey, I'm going to pay 6 million simply because it can be launched next day. But again, our opposite can also happen. There's like, bro, we're gonna launch it tomorrow, but it's like we're gonna charge 12 million, and market price is like, you know what, this service is not worth $12 million. So they're like, okay, use PSLV. So you have to understand, there's almost like a feedback loop here. Everything has to be within limit. It's not like, oh, real estate always goes up. No, it never goes up. It's like remove inflation from the equations, and you're like, like price growth is very, very minimal. It's the inflation that why it feels like it's only going up. It's because of inflation. So, and again, think about it now. Like, how much somebody can charge for a house, as long as people are willing to live in it. And you're like, okay, I'm never gonna rent it. Yes, still you are not making money out of it. At that point in time, you have dead asset or black money to white money asset. So that's one of the things. Same goes for rocket economics. You have to build something, you have to make it financially viable, and you may not have control of all other vectors. So company must gain competency ASAP. Now this is the most hard aspect, and this is what Elon Musk truly understood. For example, when he built Falcon 1, people are like, dude, why you was using liquid rocket? You could have used this or that, or like how many Indian startups they are trying to use solid boosters. Yes, once you learn solid booster, you know nothing. Because yes, all you can do is build other missiles. When you learn liquid engine, even for example, SpaceX Merlin engine, first iteration, it did not have liquid cooling. Basically, there was no adaptive cooling on there. So what it had is ablative nozzle, because it's just use and throw rocket. But again, they did learn how to figure out how to handle liquid oxygen. They figured out how to use RP1. They figured out injector plate. They figured out turbo pumps. All that info competency allowed them to build better Merlins. Then they kept improving. They're like, okay, this part is a fraud. Okay, now we have, completely properly liquid cool system, meaning we can run the systems a bit hotter. We can get more oomph out of it. That's how they did. And then they're like, okay, more and more iterations, competency grew. Then they created a new puppy, that is Raptor. Raptor, because of the competency they gained from Merlin, they had closed loop system. And now they have GG amounts of engine power. So competency is the critical aspect. How quickly you build the rocket, that itself is not that impressive. Are you gaining competency? Meaning you can try to be like, I'm building a solid booster rocket. So yes, are you gaining competency? Like, will this rocket allow you to make another rocket that is a bit better? If no, then it might be useless. And that was the true thing that Elon Musk did understand. That's what I do respect about him. He is a bit cuckoo about everything else, but that thing he does understand. That's like, if you're not failing, you're not innovating, and if you're like, iterate as quickly as possible. So you have to gain core competency. That's the final nail in the coffin. That's why many companies will come in the right now, the flooded market of rocket launches, and majority of them will die out. That happens in almost every field. Same happened with aeronautic industry. There were hundreds of car companies. There were at peak, there was around 150 car companies. Now there is 2.5 in USA. So this happens. This is one of those things that you have to understand. The company that gains competency as quickly as possible, that's the company that is going to survive. So this was my presentation on basically rocket economics. Hopefully you have liked it, learned from it. In that case, please click the like button, share it among your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.